This is Andy Tube. In this video I'm going to show you the wiring and the motor for the Singer model 237, and this would cover the 239, I'm sure. Let me go back for a second. If you saw my foot controller or foot pedal video where a couple of these little rubber pads were missing and I peeled off the other two that were hard, I replaced those now. I went to the hardware store and bought rubber grommets. I bought 2 rubber grommets for 85 cents, and then I cut them in half so I'd have 2 little pieces here to glue onto the foot pedal, and it came out real nice. They're just barely smaller circumference than the original, and they're nice and soft rubber, and they won't let the foot pad skid or anything. And for something like that, I use this Pro Seal RTV silicone adhesive. It's worked real good for me. I think this one I got at Walmart for about $3 or $4, and a little bit goes a long way. So all I did was scrape off any residue of the old dry hard rubber pad, and I cleaned the metal with alcohol, and then just stuck a little bit of silicone on there and pressed these on, and it came out real good. So a good solution for 85 cents. And then when I was looking at the motor, I found, maybe you noticed this before, there was 3 areas that had this black electrical tape. So whenever you see that, that's always a concern on electrical cord. And it's easy enough to replace the electrical cord, but I really like this old style vinyl because it's a lot more soft and flexible than all the new cords you get. They're real stiff, and usually you can only find black. Sometimes you can like buy say a 6-foot brown extension cord and just cut off the end of it and use it. But what I did was on this first one, which was under this red area, I cut. Well, let me show you. Here's one here. See, when I cut and removed the tape, what I found was just some like cut marks into the vinyl insulation. Okay, the wiring is not damaged. In this one, if I fold it back, I see a little tiny pin point of the copper wire. I mean, just barely. But still, that can arc out. You don't want that. So this one over here, when I took the tape off, it had just these 3 or 4 little cut marks. Like this got, I don't know, dragged on something sharp, like the edge of the pedal, or crimped in the case, or maybe they tried to store this under the machine in the carry case, and this got pinched by the machine and damaged. And this one didn't even have any wire exposed. So I peeled off the tape and looked at it and said, great, I can fix that. And I put masking tape on both ends for the area that I wanted to cover, and I use this product that's called liquid electrical tape. I usually buy Star Bright liquid electrical tape, and this one is red, of course, but it comes in black and green and white. I've seen those before. And it's about $6 or $7 a can. And it's flammable. It's real stinky. stuff. But what it does, it has a brush applicator under the cap here. Let me show you that. And then you need to stir it up real good, and it thickens up a little bit. And then you just get it on the end of the brush, and you just brush it on the area real slowly, and your brush strokes will go away. And it takes about 5 minutes to dry, to the point that you can put a second and third and fourth coat on if you want. I just put 2 coats on this, and I hope you can see it here. It dries pretty smooth. So that's one of my favorites. And when I take the lid off, I just stir it with a barbecue stick, you know, for 2 or 3 minutes, and mix it up good and make sure the thicker part at the bottom gets all mixed up. And then you know, I wipe up the barbecue stick just on a paper towel and reuse it. And I spilt 1 drop here, and I wiped it with the paper towel, and later I could see some residue. So I cleaned it with the same thing I cleaned the cord before I do this. Because when you tape this electrical tape off, the adhesive residue is all over there. So I cleaned that, and I cleaned up my tabletop just with the goof off, to clean off the old mastic from the wire. And I just use an old t-shirt rag, and because your liquid tape is going to stick a lot better if the surface here is clean and dry, of course, right? So it cleans up just like that very quickly. Okay. And then I would put the masking tape, just about a $2 roll of masking tape. I'm sorry. That was a warning to me to close the goof off. And I'll tape it off on each side, maybe like about a ½ inch past those scuff marks or so. And then I'll put a couple coats of the liquid tape on there, and you let it cure 24 hours. You can put more coats after 5 minutes, but they say, you know, let it dry for 24 hours. And then once it's dry, I just take a little razor knife, and I very gently go around it right at the edge of the tape, and because you don't want to put new cuts into the tape, right? And then I peel off the tape and any overpaint that I've got on it. Take that off. And now, that's showing up, I hope. You can see where I've scored it with the razor knife. If I would have painted more over onto the tape, it probably would have peeled all this off. And the thicker you put this on, the easier it is to get off if you ever have to strip it off, because it's less stretchy than this. But I just peel off the excess so it looks nice and neat. Some people don't like this. Some people will just put tape. But I like using this liquid tape because it can take heat up to 1700 degrees. And it stays real flexible like this forever. And the vinyl tape usually starts losing flexibility and starts getting loose, and you know, the adhesive collects dust and stuff like this. So this for me has just been a better solution. So I showed you this other one that I'll be doing the same thing on, but let's look at this third one, because they really put the tape on here thick, and I want to make sure like they don't have a splice or something in here. How bad the damage is. A little bit of the wire exposed doesn't worry me, because this liquid tape insulates just the way the electrical tape does, you know. But let's cut this off and let's take a look in here and see what's going on. There's a little bit more. Yeah, this was that's why they put a little bit more tape on here. Can you see that piece of wire right there exposed? The copper wire exposed? Yeah, and then you see all the... They didn't even trim off the part that got pushed out. So this definitely got caught under the edge of the machine or something when they were putting the cord underneath it. So I would trim off this stretch out piece of vinyl. We'll get rid of all that. Make it nice and smooth. And then it'll be the same kind of thing. I would take my goof off, and if you have some other adhesive remover, you know, whatever, you just want it to be really super clean and dirt free and grease free and dry for the liquid tape to adhere very, very good to it. Just a little bit left over here. Okay, now the reason I'm going to keep this cord and go ahead and insulate that with the liquid tape is because none of the strands of the copper in here are cut. I can see no ends sticking up or damage to the wire itself. So the wire still has integrity, but of course you don't want bare wires anyplace. So with this one, I'll be doing the same thing like I did here. I'll tape it off on each side, and I'll put 2 or 3 layers of the liquid tape on there. Let it dry real good, and peel off the tape. And I will keep the cord. Now, you know, if you're not into that, I mean, for this was, I think, $6.98 at Home Depot or Lowe's maybe. You could probably buy a brown 6-foot extension cord and, you know, just cut off the receptor at one end, use the plug end, and rewire into here. But I like to keep this. I think this is a better quality than the new stuff, even with some minor damage. But that's going to be up to you. I just wanted to show you how I had put the rubber grommets on the bottom of the foot pedal, and how I repair minor damage to the cord. So if any of the strands were cut in here or broken, or definitely if there was some kind of funky twisted wire splice or something, it's pretty close here. I could either cut the cord and rewire it in and shorten it by 6 inches, or get a new cord. Okay, now let's next I'm going to take a look at this motor. In a way, it reminds me of the motor of Cute on the 99K I did, if you saw that series. Doesn't it kind of look familiar? It's got a motor mount bracket that this screws on underneath the hand wheel to mount the motor, has a wire coming up to a light fixture that screws on the back of Stella, and it is a little different though that it's got kind of this splice box area. It's got an area down here where the wires go through these vinyl grommets and plug into this. So I want to see how they're spliced together, probably twist or crimp splices. But when I can see that this cover part right here with these two screws, I can see the screw goes right underneath the motor and screws into the motor mount, right? So I think when you unscrew that, it's going to take the motor off, and it's going to what looks to me like a little cover plate here. So let's just well, let me clear up some of this stuff and then we'll get started on the motor. So let's take out these screws that go through this little splice area and into the motor mount, so we can see what's going on in there. If we had to replace the cords or wanted to, this is where you would open up and redo the splices and pull out the old wire and put the new wire through the vinyl grommets there so they look nice and neat. Yeah. Okay, so that is a cover plate. So here's the two screws that go through the cover plate and into the motor mount bracket, and that basically holds the motor to the motor mount. Here is the motor mount on the back side. It's the back side of the little, what I call the splice box. And there you see the splicing. So you see which one of these cords is from the pedal. This cord right here is coming from the wall, and you see the strain relief horseshoe there, and you'll see the little vinyl grommet, right, with the wires pushed through. See, you can pull out and push through. If it's a tight fit, just use a little dish soap, and then might as well just pull this out too. 1, 2, 3. So the three-way comes from the light and the motor and to the wall, or to the foot controller. That's how it makes the circuit. Okay, so you see that, right? These can be moved. You can replace the wire, push it through the grommet. What's a little bit different about this motor is that where the two covers came off, the 99K motor, I think these two covers will still come off because I see two screws up here on the pulley end, just like on the 99K. What I'm seeing here too is some brush covers. That kind of looks like the bottom of a PA motor, like in the 301, 401, 403, 404, the 500 Rocketeers. So these are going to be removable without taking the motor apart. And I'm guessing with the ventilation and stuff here, they're going to expose the carbon brushes so that you could replace the brushes without taking the whole motor apart. Yeah. So that is a brush cover, just like on the PA style motor, and a little brush cover screw. And here we're exposing the contact from the wire, and the carbon brush and spring are right in this holder to push it up against the commutator right there. Just like in a PA style motor. So let me show you how you can just take that. Now that you have the brush cover off, you can pull out the carbon to inspect it or replace it. So with this brush cover off, you see this brass tube right there. It's pushed into a slot and it's held in place by this kind of a wire spring that is soldered to one of the wires from the motor. Okay, but if you want to, I mean, you can actually see the carbon brush up against the commutator right there, and I can see the other end of it back here. So it's well over a ½ inch long, and then after that is the spring compressed in behind this tab. So if I just wanted to see if my carbon brushes were going to last me a while, or if I needed to replace them, I'm done. You don't even have to do anymore. The Singer guys I talked to said they usually, once these brushes got down to a ½ inch or less, that they replaced them. On personal machines, I've let them wear down a lot lower than that, as long as they were still functioning properly. But if you do want to replace them, or if you want to get in here and clean the commutator, all you got to do is just tilt them up and pull them out, and just be aware the brush is spring loaded in there, right? So you got to hold on to it or it's going to come flying out. But you see how I tilted it up away from that tension spring? Oop, there we go. And it just came right out. There is the carbon motor brush, and you see it's got a little wear pattern from sitting on the commutator, and it's got the little spring that keeps it pushed up against the commutator, and it's got plenty of life left, and it's in, hold still buddy, it's in good shape. So we have a nice clean motor brush with life left. So let's take a look at the other one, since we went this far, right? Might as well pull the other brush cover off and make sure that this one over here is in good shape. Same thing, same plastic brush cover with a steel screw that holds it in place. Same little square tube that holds the carbon brush, and it's in a slot and it's held in place from tension from the contact spring. So I'll just tilt it up out of that tray a little bit at an angle so I can pinch it, slowly pull it away so the carbon doesn't come flying out. And there we go. It's just like the other. See how they're nice and evenly worn, which they should be. I'm going to see if I can find out the part number on this in case you do need to replace them. You can buy a set of carbons for, I don't know, 10 or 20 bucks probably. Now we have both carbon brushes out. Let's see if I got a Q-tip in here. The commutator looks pretty dirty, so you can clean it in place. You can dry brush the carbon off. I've used alcohol there without any problem. Or you can disassemble the motor farther, and you can scrub it clean, you can sand it clean, you can use some electrical cleaner. I bought some electrical cleaner to try that. So I think I'm getting the low battery signal right here, so let me charge up, and when we come back, let's take the rest of the motor apart in case you ever have to do that, or if you just want to see what the hell is in there. Oops, what the heck is in there. So stay tuned. In the past, I have cleaned the commutator just with only the brush covers removed, and I think I mentioned with Q-tips and alcohol, something like that, gone in and cleaned it up a little bit. But I'm going to take this front cover off here if I can. I've got the screws in the back side here that I think are going to go into this threaded tube here that takes the screw for the brush cover. That's how it is on the PA style motors that Singer made, so I'm thinking this is going to be similar to that, but we'll find out here. Yeah, I can see these. I can see this pushing up as I untwist, so I'm going to hold that brass tube in with my finger. Hold it steady while I take out this screw here. Yep, there it is. So let's do we'll turn it around here and hold the other one. Now this one, sometimes these pulleys have a little set screw down in the V of the pulley where you can go in and loosen that set screw and pull the pulley right off. I'm not this one doesn't have a set screw, and I'm not sure if this type of pulley is just held on like a push on pull off, and I'm not that interested in removing the pulley if I don't have to. I really want to expose the commutator, and oops, why does that look familiar, huh? The little stay just from the, like a, okay, it is just like a PA. So I'm going to loosen these clips out of the retention area now so that I can lift this end of the cover right off. There we go. We take out those brass tubes. Okay. So this is the tube that I had mentioned. It sits in there. It's, what is that, hexagon, 6-sided. It's a double, you know, it's threaded all the way through. So this cover mounting screw goes into one end of it, and the little screw for the brush cover goes in the other. And the threads are the same on both screws, so it doesn't matter which way this goes back in. And this little piece, which often falls out and then you don't know where that's supposed to go, I'll tell you now in case you get ahead of me. When the cover goes back on together, this little stop piece, it's just a little bent piece of metal, and it just goes right in there to keep the core from moving when you put it back in. It just fits up in here. This actually looks pretty rusty. I've never seen that before. Now this, I think now I can pull this right off. Good. So I don't have to remove the pulley or anything like that. Now we can get a close look at this dirty commutator. Just like the PA, there's a little fan down in there, little fan blades. So when that spins, it helps pull in air to cool it. This is the part I'm real interested to clean. That's very, very normal, what you're seeing here, that the commutator gets carbon deposits on it like that. So let's put the cover over here. Put the other part here. See the wiring, the little spring clips I was telling you about. Just like a PA motor. I should put the link to that series I did on restoring a PA motor, PA style. Usually now what I'll do is clean this and then run some sandpaper on it to finish cleaning it and smooth out the little grooves that get worn into the copper. But I bought some electronic cleaner and I want to try using that to see if that will get this area cleaner. So let me get set up for that and we'll try it out together. So this is the product that I'm going to try. The company is CRC. It's called QD Electronic Cleaner. Quick dry formula. Cleans and protects sensitive electronic equipment, helps prevent contact failure. It's plastic safe and leaves no residue. And there is a ton of warnings about the flammability of this and electrical shock hazard. And you know, it's interesting, they say disengage and de-energize the equipment before you use this spray. I just figured I was going to try it because it looked easy, and I thought if this will work to easily clean off that carbon, then you know it would be worth it. And I'm sorry I don't remember. I bought this when I was at the hardware store, and I don't remember the price. I'm sorry. Let's get this off of here, and I'm going to use the little straw. It does say to apply it in short bursts, and it also says that you can use lint-free cloths or swabs to clean stubborn soils. So in case I want to do that, I got my trusty t-shirt rag here. But I'm just going to give it a shot here and see what happens. Looks like a big waste of money to me. What do you think? I had visions of this black carbon just dripping off like crazy and running away. Let's see if using a rag on it is any better. Nope. Gee, it's like I'm gluing it on there more. So maybe this electronic spray isn't the best thing to use in this situation. Oh, too bad. Let me grab some alcohol or crud cutter and see how that does. Well, I can tell you that stuff dries and it just like disappears. So they're correct about that. Maybe I can clean my computers with that spray. I'm just going to go to my trusty 91% alcohol I buy at the drugstore, and I'm going to try that. See if I can get some of that carbon off with that. Yeah, not much going on there either, huh? Okay. I think I'm starting to remember why I used the fine grit sandpaper. Okay, let's try. This is about a 25% solution of crud cutter. Give this a whirl and see how that works. Barely budged it. A little bit, because I got some on my thumb and I'm getting thumbprints all over everything now. Yeah, it's just embedded right into the copper. That's the thing, the copper gets etched, I think, and the carbon gets deposited in there, and I'm sure it's hot. You know, I'm sure when it runs it gets hot. So it's just not doing much there. Now I have seen fellas in shops take big electric motors and mount the shaft here and everything onto a lathe and take a cutting or shaving blade and run it into those giant commutators and just shave off microns of the rough copper where it's been grooved to smooth it out. Because the smoother that is, the better contact the carbon brush can make. And that's how they do the very big electric motors. Yeah, that's not doing too much. So let me dig around in my drawer here and find my sandpaper. Okay, I found my my sandpaper or emery cloth. This is 600 grit, 1000 and 1500. And I'm going to start with the 600. And now, you know, I have a Dremel tool and I have buffing and polishing attachments for it and little clay compounds. But I've avoided that, and I've always used the sandpaper because my concern is that if I use that Dremel, it's going to create low spots, low and high spots, and I'm going to lose my little curve on these little copper pieces. and you can see how thin they are. They're not very thick, and they have a divider. Those little black lines you see in between are little spacers of the dividers, and I was told years ago that the Singer motors, that's made from a mineral called mica, and that you never want to get the copper below that divider level, and you always want to keep it even. That's why, like on a lathe, you know, it cuts it super even. So that's why I don't use a power tool to polish it or anything. My goal is not to get it shiny, but to keep it smooth and even. So anyway, that's why I've always just used a paper like this. And I know people can have put, you know, you can put this on a drill and turn the drill on and have it spin like crazy and just hold the sandpaper. And I don't do it on the PA motor because of the bearing up at the top of the shaft, and I'd be a little bit worried about all that, the weight. But you could probably use put this into a electric drill and turn it fast, but I just do it like this so that I can. This is where the friction is going to be, and it just follows the curve, and it stays pretty even. So I'm going to do that. In the beginning, I'll just go back and forth, and I can rotate the shaft and the commutator a little bit as I go, and just keep doing it like this. We'll see how the 600 does. I have some 400 too that I've had to use before on commutators that were scratched deeply. So we're making some progress here. You can see now the grooves kind of cut into the copper. Instead of just a big black streak, now you can see individual streaks. We move to another little place here. So I just like to clean this up and get rid of as much as the copper that I can without you know, damaging the commutator, or taking off so much of it that it gets down to the level or below of the little separators. It's like watching paint dry, huh? Nice progress. If you look here on the paper now, you're going to see the copper that I'm taking off. You see it? So going to a finer paper is not going to go any deeper into those grooves. I could use the 400 and go deeper, but then I'm taking off more copper. So I'm just going to do it a little bit more and say that I'm happy. How's that? Like a physician, first do no harm, right? It'd be better that you didn't do anything than that you broke one of these little wires going into the copper, you know, it'd be better off if you never did anything with it. If you just opened it up and said, yeah, my carbons are good, or you opened it up and said, wow, my carbons are shot, I'm going to put new carbons in, and then closed it back up. So I'm going to just wipe off any residue here with alcohol. Let that dry. So that's how it looks now, and I'm good with that. I'm satisfied with that. So I didn't need to use my, well, let's put the 1000 on there and I'll show you. All it's really going to do is the copper that's already exposed, it's just going to smooth it out a little bit more, and it's going to shine it up nice and smooth. So you can go ahead and go through the progression. It's not going to get any of that residual carbon off of there. Just smooth out the copper that is exposed a little bit more. So, by the way, I looked through all my documents that I could find, and I could not find a part number for the carbon motor brush for this motor. So I measured it on a flat line scale, and what I came up with for the size of this carbon is 5 millimeter by 5.2. It's not quite square. 5 millimeter by 5.2. So if I had to replace these, that's the ones I would buy and attempt. And let's say it's 5 millimeter by 5.1, and the new carbon was a little bit too big to go fit in the tube properly. See, if I turn it this way, it's a very snug fit. If I turn it this way, it's a little smoother fit. So a little bit. I would. What I started to say was, if the carbon is too big, you can take the side that's too big and you can gently rub it on some of this very fine grit paper and wear down the side and get it to fit. Because what are you going to do? Toss out a perfectly good motor because you can't find an exact carbon fit? I wouldn't myself, you know. But I would start with the 5 millimeter by 5.2 millimeter carbon. And I said before, the Singer guys told me that they replaced the carbons at about a 1/4 inch, and I've run them down to about 3/32 without a problem. It's just if they start getting real short, you know, I'll check the carbons more often, depending on how much the machine is in use. You know, my wife's machine, I'll maybe take a look at it every 3 months. And with this type of motor, it would be easy just to take off the brush cover and look and see how much you have left. Okay. And I have bought carbons, extra carbons for all of her machines, because I don't know, 10 or X amount of years from now, if I need a carbon replacement, are they going to be available? So if you have a vintage machine, you might want to spend 10 or 20 bucks on a carbon, a set of carbon motor brushes for them. Just a thought. Okay, so I'm going to reassemble this now. The rest of the motor looks clean enough inside. You know what? Where was that little rusty stop? That kind of bothers me. It looks like rust, and I've never seen rust on one of these before. So I think I'm going to go get my rust remover real quick and see if that is rust. The rust remover will take it right off. This is the rust remover that I use. It's made by Crud Cutter, the Must for Rust. It's about $5 for an 8-ounce. It's the only rust remover I have ever used, and it's the first one I tried, and it works great in my opinion, so that's all I've ever used. But I've had several people tell me that they use Evapo Rust, and that it's a good rust remover also. So I'm just going to pour a little bit of there, use it at 100%, get some on my cotton swab here, and take a look at this and see if it's really rust or not. Put some on here. I didn't see any other rusty parts in the motor. Looks like it is rust and that it's starting to dissolve. I don't know what this it's that discoloration right there on the front of that motor. Doesn't appear to be rust because it's not dissolving off of there. So it must just be whatever kind of plastic or mineral that's made out of. So that's good. Just this little thing got all rusty. And it looks like the Must for Rust is cleaning it right up. Yay! So at least I had success with one chemical today, even though my electrical cleaner didn't affect the carbon. The alcohol didn't affect that. I've used alcohol before when the carbon deposits are real thick, and it has taken off probably just the surface carbon. Okay, that looks good. Let me put a little drop of oil on there and spread it around so that hopefully it will avoid the rust in the future. Okay. Now we'll come to the little. Also, you can clean and polish these if you feel the need to do that. See, where's my little 600 paper here? This part of the outside, especially, that rubs up against that brass tube that holds the motor brush. You want to polish that up a little bit. It's certainly not going to hurt anything. I've used metal polish on them too, and I've used my Dremel wire brush. Will polish these up real nice too, if you'd like to do that. right? You can take the side of this that is going to fit up against that piece, and you can polish that up nice if you like, so you get a nice good contact. There we go. If you want to see a little bit more involved restoration of a motor like this, like I said, I'll put a link in the end panel of the video where I have the YouTube lets me put a 20-second display there with links to other videos, and I'll do it the restoration of a PA style motor from I think it was from a model 403A. Okay, so I'm going to stick this back in now, and of course this is my wiring bundle, and this is the little what I call wiring box area. So we want it to be like that, and stick it back in there. And you see there's some kind of in the molding there, they left spaces for these black and yellow wires to come out of there, right? So you don't want any wires pinched in here. Righto. And then this little stop or keeper is going to go push up right in this little area that's made for it. Push it in there. That has a tendency to slip out while you're working on the motor, so you keep an eye on that. The tricky part here is that these motor wires and the little contact springs have to be fished out of these openings when you put it back together, because later you've got to tuck it in the cutout so that the brass tube that holds the motor brush can slide in against it. That's how you get electricity to the motor brush, or the motor brush, right? Okay, so see, it's going to go on like this, and then that this wire has to, and don't forget your little stop up there. It's going to end up in this little area. So we'll try and get them started here. See if I can. The less you bend those wires and contact springs, putting them in, the less you'll have to reform them and stuff to get into the area. So here you can see I kind of have one in an accessible area. Where's my green one down here? Oh, it got tucked way down below. So let me try and redo that. Get my green one here where I can see it, and the brown one. Get some little pliers here. This green one is the one that's a little bit tricky. So gently, because it's soldered to that wire, a little tiny bit of solder, so be very gentle. Turn it around this way, see how my brown one is doing. Got my stop is still in there. Yay. Okay, there's the brown one starting to come up. So let's see if I can gently, because I have to get the yeah, forgot to tell you, there's a little bushing up here that the end of the motor shaft goes in, right? So when you're putting it back together amongst all the other things, you know, you have to get the little motor shaft up in there. And Singer never says anything about lubricating that, like in the very old motors. Some of the bushings and bearings, you know, had wicks, and you put in a special motor lube from the little tube. If you like, you can put some lube or grease up in there. I guess I will, since I'm talking about it. And I just use my Tri-Flow clear synthetic grease because of the heat rating is so high, and it does not liquefy. Let's see if I can get a little bit on my Q-tip there, and I'll stick it down in there and gently deposit it. Okay, so back to the reassembly now. See, my little stop keeper thing came out, right? Just like I figured it would. So I'll put it back in there. Then I'll try and get my brown and green wires lined up again. Oh, they're a little bit better because I moved them before. So, get my wires out of the way here. All I want to do is get that thing to sit right down on that armature shaft and get the two ends together. So my little stop is up in there. Look at that. That looks pretty good. Make sure I can move my wires just a little bit. I don't want them pinched on anything in there. So I'll be able to tuck these back in. Hey, there's my little parts now. I'll put my little hexagon threaded nut in there. Okay, and then holding that nut and the case together, take my case mounting screw and wonder why it doesn't go in there. How about this side? Yeah, what's wrong? What's up with this one? Let's work on the other one so we don't get frustrated. It's kind of a family channel here, right? I don't want to say bad words, so see if we can get this one. Whoop. See if we can get this one to start. I'm starting to wonder if I had the wrong screw on that other one, because this one just went together like butter. Snug it up nice. Don't break any of the plastic parts. But it's tight now. Now I don't have to worry about my case falling apart. So, yeah, see that thing? There's something blocking that. Let me check this out. Okay, so I took this cover back off and pulled out the screws and nuts and everything, thinking I must have picked up some debris from my workbench here that was on the thread of the screw or inside the nut, and I didn't find anything at all. And so of course when I put it back together, put the stop in and put it back together, then everything went back together normally. So isn't that the case? So I'll tighten up these two screws so this end of the cover will be snug in there. Let's get the other one here, and then I can put those little wire contacts back in the grooves, and we can get the motor brushes back in there and reassemble the motor and test it. Make sure I have this one tight. Up a little bit more to go. Okay. And then I've got the cover, two pieces made up together fine. Alright, so what we've got to do here, see, I get my light back on, sorry. What we've got to do here is tuck these little wire clips back in the slots for them to prepare to slide the tubes back in with the brushes. That one folded down in there, nice and easy. Let's see if the other one will go in that easy. Sometimes they tend to want to pop out. That one went in nice and easy too. Well, that part went pretty good. So let's grab one of these tubes and one of the brushes. And when you put the motor brush back in, you want to be sure the wear pattern is the same, because the commutator is curved and round, and your carbon will be worn that way too. So you don't want to put it at cross purposes. You want to put it back in the same, so the curve matches the curve and not across from that, so you have like a little gap. So I just put it in there for a second, and when you put this in, if you put this slotted open slot side up, you'll be able to check your carbon in the future, right? Then push the carbon up against the commutator and use one finger to hold that little wire tension in there, and slide the brass tube up on to the motor carbon and get the carbon to go inside of it there. See? There. So I've got my wire clip in there that's bringing the electricity. I have this seated all the way down in the little tray, and the carbon motor brush going inside that brass tube, and I'm going to push it up until the back piece is flush with the curve of the plastic. You don't want to push this so hard that any of the brass tube touches the copper commutator. That's a big no-no. If you want to check it, you can take your brush cover and put it on there and use it to push that brass tube up to the right position. I don't know if that made sense. Let's have it so this sticks out a little bit, okay? Then if you put this on and use it to push up like that, then you'll know, of course, that the brass tube is in far enough that you can get the cover on, but I still have a big distance from the brass tube touching the copper commutator there, so that is perfect. And then I will go ahead and take the brush cover screw and put it in there. and I'll just tighten this up and this side will be done. Okay. Perfect. Okay. Let's work on this one now. So, once you got your clip, whoop, see there? Once you got your clip in there, hold it down, get your tube in there. That's why I usually just put the carbon in there first and then slide the tube, maneuver it a little bit so it slides on there. I'll leave this out again just a pinch so that I can push it back in with the cover. If you do it that way, you'll never have to worry about the little brass holder rubbing up against the commutator. See if this one will go better for me this time. Yeah, there we go. It started in right away. That's more like it. Okay. So, now I still have to, put the cover plate on and mount it to the mounting bracket. But just in case I've pinched a wire or done something wrong, I'm going to go ahead and test it now rather than have to take that all off again. So I'm going to plug in my power cord and I'm going to take my foot controller, and there we go. Yay. Let's raise this guy back up now and get a little bit more angle on the view. Perfect. Unplug the motor. Now, so you got these all kind of twisted around here. So let's get these back in, tucked back in. I'll get the grommet tucked back in there if I can. Didn't really pay attention to which side of that grommet was up or down. I don't think it matters. As long as we can get everything neatly inside the little containment area. Got my strain relief. That looks good. Tuck down these crimp splices. Okay. Then let's see, how does this go on here with the nameplate up. Like this, and then the tray sits on there to support the weight of the motor. Uh-oh. That's not good. Let's see if I can tuck these back in here a little bit better. No pinched wires, okay? Okay, cords on the bottom, Singer nameplate facing up so you can read it. Motor mount with the extension going underneath. Let's try this. So that's how it's going to be mounted to the end of the machine under the motor. Looks a little bit loose, but let's see if we can get these screws started in here and get it all to come together. Then we can align it as we tighten it up, maybe. So if you remember, this screw is going through the cover plate and into the hole on the motor mount back here. It feels like that one got started. Maybe I'll loosen this up a little bit until I get the other one started too, because I want that motor, that plate, cover plate, to sit evenly on here, right? Now let's try the other screw. If you remember, it just goes through the hole and it kind of rides under that splice box, I called it. See if that's going to line up well. And it does. I'll tighten these a little bit at a time so they tighten up evenly. Just make sure I don't have any pinched wires anywhere. Have my grommets. That looks good. Go ahead and snug these up. I think we're just about done. That one's firm. That one's firm. Ta-da! So I'm going to plug it in, run it one more time just to make sure I didn't pinch a wire or anything with this cover plate and mounting bracket going back together. Nice control. Strong little motor. Of course, it doesn't have any strain on it yet, but nice little motor. And again, right at the end of this, in the end section, the little 20-second slide I can put on there, I'll put a link to the series of restoring the PA motor. If you take a look at it, you'll see how much of these interior motor parts look the same as the PA style that goes in the 301 and the 401, the 500 Rocketeer, even the 600 and some of the 700s like that. The internal motors, where instead of this housing they put the Bakelite and aluminum piece to the PA motor. That's going to do it for the wiring and motor on the Singer Model 237 Stella. So thanks for watching that. I hope that was worth your time and that you will be enticed to come back and see some more of my videos on AndyTube. Take care.